Hello, I'm Stuart Ekblad. I'd like to talk to you about CIDCI, which stands for the Center for Innovation in the Design and Construction Industry. This is a new organization that's founded by owners, designers, builders. Our goal is to accelerate the awareness and adoption of innovative processes, innovative tools, and invention into the design and construction industry. So we believe that the industry itself has seen a huge advancement in the number of innovations. Unfortunately, the adoption is disproportionately slow to the number of new ideas. So what we've envisioned is, in fact, through collaboration between ourselves within the design and the building industry, but with other industries, to find new ideas and find a way to accelerate the adoption of those into buildings and construction. So our goal is to create a professional network that, in fact, is set up to learn, to share, to exchange ideas. So our mechanism to do that is to hold 3 forums a year.
Good morning. My name's Jim Bedrick, and I'd like to welcome you to the second in the series of CIDCI forums. And today we'll be addressing the question of what is the next dimension of building information modeling. 3D modeling is now mainstream. 4 and 5D have been taken up by time and cost. And now facilities operations is emerging as 6D. Well, what's next? So today we'll explore 2 possibilities. One, we'll talk about hypervisualization. What is there beyond simply looking at a 3D model on a flat screen that'll help us build buildings better? And second, we'll address data-driven design. Rather than creating a design and then querying the model for data on how well we did, how do we use that data to help us create the design?
I think the focus here is making digital construction of a real object directly from scientific data. Right now, we need a model, and if the model isn't there, we can't do very much. The second thing is that quality seems to have been left out of the equation when you look at the masses. We have the tools to make really, really powerful, great models, but there doesn't seem to be I don't want to use the word standard. There doesn't need to be a protocol for developing a high-quality model every time you put your fingers on the keyboard. Classification is a key to a well-structured model, and you learn this over time, is that it's the content going into the model is very important, but how that information is created consistently and how that information can be sorted once it's in the model is where you get the power of the data. The model as a carrier of information, I think, can really fulfill the promise of BIM. It was about data reuse. It was about doing something once and then having other people be able to use that same data for maybe other purposes, or just different parts of the data for their own specific purpose. Right now, we're not really fulfilling that yet. We're very fragmented. We're start and stop. We have great data sometimes. We have not great data sometimes. But the idea is that the model can carry this, and then the topic of visualization can really make that a positive experience or a negative experience. And there's a lot of paper being burned, being used in all sectors of society. And if we're looking at green, looking at sustainability, those are things that are, environmentally we should be conscious of. Going paperless is not a bad idea. How do you visualize, what you're looking at so that the audience can get it? And I think what we have learned is 12 people around a table with 2 at a time bent over drawings looking at what's going on is not as effective as 12 people around a table looking at a model and seeing the impact of multiple disciplines in their space. The other part of it is you're working in 3D to build the model, you're flattening to 2D, then you're giving it to them, then you're going back and repeating the cycle. That's the break right now, to me, in BIM. So that whole industry is still on paper. Okay, they're moving gradually to PDFs, and they'll say, yeah, we're going green, we're doing PDFs. Well, what about if you had a model? Wouldn't that make life easier? But there's a lot more in the model than just the objects. So if you have a tool, let's say, for example, you have Revit. Revit's a wonderful tool, has a lot of data. But if you're only taking quantities, you're not looking at about 85 or 90% of the data that Revit is giving you. So we created a functionality called information takeoff that says, tell me everything about that model, and I can, again, sort it by criteria that's important to me. So this is a current project, and now we've finished phase 1 of the project, which is proof of concept, where we took 14 separate jurisdictions reviewing the same set of plans, and you would be amazed if you think that the construction industry and the subcontractors were siloed. If you saw the results from 14 different jurisdictions across the country and the inconsistency between the results, you would be amazed. We had 191 comments in total, and one entity found 46 things wrong, the other one had one. Same set of plans. Okay, and when somebody has one thing wrong, they didn't look or they didn't care. And the last thing I'll say about it is there's no dialogue. It is pass-fail. They just say you didn't comply with this. You don't know why you didn't comply. The technology, through visualization as well, can say your issue here is the threshold's not wide enough. It's 36 inches, needs to be 42. We're not telling you how to fix it. We're telling you what the problem is. You don't have to go search to find out what is the issue that I had with my building. So I think Solibri is already innovating in the world of visualization, but actually we're innovating from the data and we're relying on the visualization to tell the story.
Graphics processors, which didn't used to really exist, have become phenomenally powerful pieces of computer systems to the point where arrays of GPUs are now being used to solve complex three-dimensional problems in research domains across the sciences. That doesn't mean that we're using them necessarily, although we may be through some cloud kinds of things, but it does mean that we get to have a GPU in our desktop box that is amazingly powerful. And all of that sort of flows downhill from this interest in and emphasis on visualization and pixels that was driven by an industry that could make money out of it in really big ways. So we've inherited that. What might we be about to inherit? How we might think of the distribution of labor within the traditional contracting model said 40% of the contract lives in working drawing production. That's the place to apply this expensive tool that we're going to get. And that makes sense. I'm not so sure that the jury isn't still out on whether the computer-aided graph is accurate or not. I'm not sure that we've actually driven the middle down quite as far, but certainly a lot of the emphasis and interest in BIM is built on the assumption that if we do the front work, we get quick, inexpensive, straightforward kind of back end that gets us total cost savings. The other driver for acceptance into the AEC market was that PCs were a whole lot cheaper than workstations. On the University of Washington campus, there are 35,000 students. In January of last year, 60,000 Wi-Fi devices were present. There's a huge population of things being carried around in pockets that are connecting to the world. Most of those things have imaging chips in them now because it's become phenomenally inexpensive to add a camera to a laptop or a phone or a pair of glasses. And many of those devices are directly location aware, or the network is aware of the devices and knows where the network infrastructure is and therefore knows where the device is. The client who comes in and says, I really like this, this, and this out of Sunset or off of this website or whatever, that imagery can begin to be integrated into the process so that when you sketch, maybe even though you have a simple user interface for that process, you are actually doing collaging with some of their backing imagery so that you can begin to build a design from that kind of tool set.
This amount of data provides our fighter pilots a much better opportunity to be creative and to solve their mission in ways they could never have done simply relying on their own eyes. Part of the future of our Air Force is a combination of manned aircraft as well as drones, and the drone operators use consoles that look like this. I think the Google Glass is the beginning. I would expect that within the end of our lifetimes, every single pair of glasses will have displays within them. All of these different data sources that were previously siloed are now coming to be networked. But it's not just that, as has been mentioned before. There's a huge amount of data that is being captured both by professional, specifically built sensors and consumer hardware that just happens to be capturing a ton of data. We can actually model air circulation now in a building. And because of that, we can model what the mold risk is on various surfaces. Now we can decide what kind of flooding damage we'll suffer. How sustainable are the various materials in the building? What's the carbon cost of all the various building materials? What's the fire rating? And because of the fire rating, and we can simulate fires throughout the building. And because of that, we can then simulate what the fire teams will do in responding to those fires. What happens when an earthquake occurs? How energy efficient is the building? Where does the sunlight fall in the building, and what does that do to our energy efficiency? Material durability as a result of that sunlight. Which walls are going to need to be repaired, and what materials are going to need resurfaced because of that sunlight. So there's not just one new dimension of visualization for the AC industry. There's hundreds. And the problem is not going to be what do you want to visualize? It's how do you deal with the information overload that is coming? Because it becomes very easy to miss information when you've got seas of it. You'll start to see the rise of expert systems and intelligent agents who do that grunt work for us. So we have mechanisms to go through, and systems that run and run and run and run, and every tweak, every change, it checks. Hey, is it still are we still in compliance with the fire code? Do we still meet our accessibility requirements? How's our carbon cost doing? So you don't have to worry about that. But the thing is that while all these systems are chugging away, you don't actually want to see all that visualized. Instead, you're going to see a rise of dashboards. Because doing visualization, 3D visualization of all this data is just going to add noise, right? You're going to have noise, noise, noise. So instead, you're going to have a yes or no, a pass, fail, as much as we were joking about it earlier, a pass, fail on your fire code compliance. But what you care about is when that fire code and compliance goes to fail, you can click on that and you can bring up the visualization and instantly see where the problem is. Because speed and responsiveness are incredibly important to making the right decisions at the right time. So I believe there's going to be a hybrid approach to visualization moving forward, where in the local environment, on your local machine, you're going to use as much hardware power as you have to get your frame rate and your visualization to 60 frames a second, 30 frames a second consistently. So you never have stutters. So you can always answer the right question at the right time. And you're going to use whatever data and whatever visualization simulation you can on that hardware that's available. But at the same time, there is going to be this whole cloud component of visualization, where you have expert systems, you have all of these autonomous agents running continuously on servers external to your local machine, doing the simulations that are much more complex than your local hardware can handle. And visualization, at the end of the day, needs to make the professionals who are thinking about buildings more effective.
I've traveled with some of the students to Europe, and true, they don't have the sketchbooks, they don't have their pen and paper, but they've got their cameras and they have their little pads. When we went to some of the castles in Austria, they had it photographed, they had it digitally inputted and spatially recognized, they had it photogrammetry, they had already recognized the spatial volumes, and had it in several pages of their iPads and all this, all in a matter of 30 minutes to an hour, where I used to do the same thing, sit there for hours sketching these things out, trying to identify those spatial relationships and design qualities. They're not going to have the romance that Graves had of sitting in Paris drawing the stuff while drinking his wine and eating cheese, and understanding the nuances of who designed what and where and the Beaux-Arts or whatever. However, these kids and the younger people and even some older guys in my age going out there doing the same thing, and the architects and such, we're recognizing so much more, but just in a different way. And do I have the same wine and cheese? Yes. But it was just with my iPad and my digital pen. The new designers that we have and the old designers also are carrying their iPads now. And the fact that they can have the printed document and people look at it and we can send that information just via the web to the various aspects of either a client or other people, it's just a handy tool. We've spent the last several years in local mode. And it's just now making the migration of the technologies that we have in the real-time world and the game engines and such to the remote cloud. The complexities of getting that information assimilated beyond the 10 or 12 people in my team to the field and everywhere else is the new endeavor. I mean, that's the big part of how do you get that into people's hands? How do you assimilate that knowledge base. It's all about the model. The stuff Brian has is where, okay, there's all the different avenues of, presentation and delivery. And then the mechanics of the game engine are so different from what everybody else is used to using. The AR augmented reality kit, that was probably the most advanced technology that was implemented across our designers and presenters faster than any other technology that ever hit. I mean, it was extremely just, well done, kudos. That was really nice implementation of a fairly complex topic and system. But our guys, they were using it the next day. It's just been a really useful tool. And the same thing with the architecture and everything. I mean, we can have 200 people in the model at the same time interacting with each other from anywhere in the world. And so there's the distributed and socialized aspect of it, sort of semi faux cloud, as I call it. But the multi-user aspects of everything is just kind of naturally, that's really what's pushing most of what we do in a collaborative environment like no other, really.
Imagine a design process where you have a BIM model, click export, whatever file format, import into 2 or more analysis applications to do some analysis. You get some output, maybe you throw it into an Excel, someone analyzes it in some way, whether it's automated or not, and then you make some judgment on what the next design should be. Okay? Let's imagine we take that process and we fully automate it. This will help you spend more time on creative design, which is what your specialty is, and let the number crunching and everything else be done by a computer. Don't waste your time doing that. And let's figure out innovative ways to automatically manage that information, execute the simulations, generate this data, and then it's still the designer that takes it and tries to interpret it and makes design decisions, and it's still the designer and the architect that has to create the parametric model in the first place and decide what things they want to look at. So this is not intended to be a replacement. It's intended to be an enhancement. This is only meant as a starting point. You can visualize all the other designs and you can throw out whatever you want, but at least you have the information to do it. And in reality, the most efficient buildings ever designed were medieval castles. A lot of thermal mass, 65 degrees year-round, no matter what. Those are the most efficient buildings you can design, but no one here is going to win an award for that. So it's not about finding the most efficient design. It's about understanding where all the options lie with respect to other things you have to consider, like cost and time and other performance codes, etc. It's just providing you richer information to try to understand. This is the GSA headquarters rendering of it in DC of a proposed project to build 2 large south-facing atriums so occupants could walk between the 3 different wings that you see. But if you look closely, you see there's a lot of glass and it faces south. That could cause a problem. A lot of heat load, a lot of air conditioning load. And it's a very controversial project. Some people think it's a good idea, some people don't, and it puts a lot of stresses on the design team to really do their best to evaluate all the different options and present that to their client. Let's not automate it in one way. Let's make it so we automate it, spend a little bit more time automating it up front, so when we go to new projects or ask different design questions, the automation can just be reconfigured quickly and you can run the optimization, because if you don't, MDO won't pay back because it is costly to go through this automation process. Okay, and if you do it and you use it on a project and you have to go back and change it, it's not going to get a second chance. Okay, so really critical for industry, if they're going to adopt this, to have available methods to automate it right the first time around. In this litigious society we live in, and closing in on a point where LEED certification is going to be provisional based upon predicted, and it won't be finalized till they meter and monitor it for 2 years. What it's going to do is expose all the holes that the people that actually do the designing know about right now. Okay? And any big law firm can absorb 1 or 2 lawsuits, but no one's going to be able to absorb 20. Using MDO can help mitigate these, this risk, because it lessens that gap between predicted and actual, and it provides you a fully traceable, documentable process of what you did if you ever had to go to court.
In the future, we really want to make it available that everyone can develop checks and rules for their construction process, for constructability, for client-based design review checks. Any model 10 years from now will be too complicated that anyone will trust it as being complete and sufficient at various stages of design. Courthouses have 3 circulation paths that are supposed to be disjoint. One for the prisoner and high security, the U.S. Marshals, another one for judges and jury, and the third is the public. And they're not supposed to see each other, they're not supposed to cross paths, and there's a variety of security rules, especially on the secure spaces. We probably assessed 25 different courthouse models over that 5-year time, and we never got a model that required no corrections. Now they got very little at the end. Toledo Canon Design got really good at it, but it took them 3 or 4 iterations. The work that I'm describing here was done jointly with Jochen Teiser and his students and a couple of my students, taking a 4D schedule on the sequential construction of the building. And at each stage of the construction sequence, run safety checks. I'm just pointing out areas of rule checking where the rule checking environment then becomes part of the standard task. We don't have very many tools for checking at this kind of level, and I see a big need and a big market potentially for doing this. But let's think about the system architecture. If we're going to write rules, we ought to write them so that the language is general and it's portable on different platforms. That is, in the same way that you write Java programs and it can run on a Mac, it can run on a PC, and it could run on different application platforms like Revit or Bentley. In the upper left-hand corner is the program, and the lower left-hand corner is a kind of a dump of all the information about the spaces that are identified. So these are research spaces. This is from a central circulation space, the longest distance to fire. Here's a model of the outside walls on a floor of the building. And then here's all the rooms that are adjacent to outside walls. We're not talking about one model. And at the fabrication level, we're probably talking about N models, one for ductwork, one for steel, maybe a different one for reinforced concrete. Architectural fabrication, we have a lot of woodwork. We'll have a model for that, electrical. So let's live with it, folks. We're going to be writing these rules, and we're going to be living in an environment with multiple different models. And I'm excited about the animation model that we saw just before lunch today. But that's another model too, and we got to manage the consistency and integrity of all of those.
It's not about what is the best race car. It's how well does the race car fit the need of the driver. Whether there is rational reasons why the driver wanted some way or irrational doesn't really matter. The tools have to be customized to the needs and the style of the designers. And when you design complex problems with many people, my experience is that it's not about what methodology they use. Is everybody aligned? Does everybody believe that the way they do it is the best way possible? You can provide a lot of good tools. If people don't believe that they're valuable, you can never prove that they're efficient. People are very good at judging choices as long as you give them, the information about how their particular object performs in all these different dimensions. And again, think of it as how most people shop for an expensive item like a car and a house, right? Is that you start consciously or unconsciously with selecting some metrics, what it is that is important to you, and that might be a very personal thing. Then you establish some hard constraints, right? If you look for a car, you say it has to be a 4-door, I have kids, or whether it's a house, it might be a location. Usually a complex set of metrics. And then what you do is that you don't know how to, weigh all these different options. What you do is that, you educate yourself. You look around and see what's available. And by looking at a few or a lot, and the more, the better you get at it, is that you educate yourself for what are the trade-offs for this particular problem in particular point in time, that are available to you. And it turns out that people are able to, by looking at a wide set of samples, to come up with a very limited set of options that say, yeah, this is the right thing for me. And when there is hard choices to be made, it's usually between two alternatives that are very close together anyway. We don't have to build physical buildings. As I mentioned here, Rodin didn't create his thinker with bronze, he did it with plaster. Now, today we have something much better than plaster, and it is a virtual model. I won't talk about all of the hardware improvements and software improvements. There's been talk before about the cloud. The other thing, of course, that is a basic component that makes it all work is the web, the connectivity of all the information that is available up there. It's better and cheaper. The cheap part has been discussed before today, is the compute cycles today I can rent. I don't have to do a upfront big investment. I pay as I go. And there's even business models today that if I don't need my compute cycles here and now, I can get them at a much cheaper rate, in the low usage, say, Saturday and Sunday nights. I think this industry hasn't gone all the way, is that once you start thinking in terms of building a virtual model, you can free yourself from the physical constraints. You can start by putting the paint in the room first, then hanging the sink, and then only way later, add the walls, right? But what it also allows is it allows you to work with more abstract objects. And we heard a great example, the idea of spaces. Spaces are not physical, spaces is when you put walls together. But early in the design, nobody thinks about walls, right? And what we don't have enough is tools that map the concepts that people think in to, useful programs. And that's why so often there's sort of the feeling that, hey, I can use the tool, but I have to compromise. I have to fight the tools to get my ideas, right? I can teach my 10-year-old to look at a drawing from an architect, freehand, and say, measure me the distances between departments. I haven't seen a tool where, an architect can, with as much ease as on paper and, with a pen, draw a building and then say to the tool, give me all the distances. And there is no technical reasons it cannot be done. In BIM, there is an elephant, a virtual elephant, but it's always inferred from everybody's view of the elephant. And the information passes from view to view. And yes, there is some great tools that check the consistencies of these views of the elephant. It's the early decisions that have the biggest impact, but they're usually done with the least amount of information. So you can't really commit or should not commit to these early decisions until you know how really, and usually the devil is in the details, how these details will pan out. Right? So you have to pursue the design in enough detail that you don't have to forecast or predict, that you can sort of measure and see what the impact is. And then you can decide, between all these complex metrics, what is good and what is, what you like and what you don't like. Every stakeholder in the design needs to be there from day one. Design discipline, is, think of it as self-inflicted pain, sort of allows you to simplify your life quite a bit. And there are several instances in software design, in chip design, in all kinds of mechanical design, is that the art is in choosing the right set of standard components. Standard components that don't limit you in your creativity, but that allows the production and the design and the predictability of the design and the performance of the tool much better.
I think you got a glimpse of the sort of level of complexity that the different disciplines deal with, right? And just the amount of control that's possible to have in terms of being able to manipulate these models and be able to get them to accurately reflect the physical situation. And I think, you know, in this idea of you want to be very early stage, making, you know, helping to inform early stage design decisions, controlling the level of detail in terms of understanding which decisions are most important and what level of control the different design players need to have is really critical. And so it just resonated with me that being able to manage that correctly is, I think, a big challenge, where designers do feel like they have the flexibility to control, but at the same time, you don't overwhelm the sort of user or decision maker with so much information that they can't effectively make a decision. So I think that's a continuing challenge in the industry in order to really have sort of performance-based early stage design where you can provide information in a sort of concise way that decision makers can digest, but it still sort of is accurate and will satisfy the experts, if you will.
If I'm someone in the audience and I'm at the management level of a successful design firm and you just sold me on that speech, what do I do now that we already have a very well-established design process and we want to start migrating to implementing some of these principles? Because what a lot of firms do, say when product models or BIM came into the market, you know, they'll start with little pilot projects and kind of work their way up. But they're fundamentally different tasks to integrate a single technology versus a process.